Hello all, welcome to KT Semicon Self-Based Learning Program. Now, in this particular session, we are going to discuss how to build basic gates using universal gates. First, we will start with building of simple NOT gate with a NAND gate. So this is how your NOT gate you can build using a simple NAND gate. What I'm doing here, I'm just sorting both the inputs of a NAND gate so that it will behave as a AND gate, NOT gate. So your expression of your NAND gate is nothing but A dot B the whole bar. If you are applying B is equal to A, then it is nothing but Y is equal to A dot A the whole bar, which is nothing but A bar. So that's why if I short both the inputs of a NAND gate, then it will behave as a NOT gate. Now, if I want to build a simple AND gate using a NAND gate, this is how I'm going to build a simple AND gate using a NAND gate. How I'm going to build, I know already the expression of my AND gate is Y is equal to AB. But if I double complement this, then what I'm going to get is nothing but my AND gate. Okay. So I'm going to take first a simple NAND gate. So I'm going to get A dot B the whole bar. And if I'm going to give it to another NAND gate, then I'm going to get A dot B double bar, which is nothing but A dot B. So this is how you can build a simple AND gate using a NAND gate. Now, let's say if I want to build a simple OR gate using a NAND gate, how to build it? So this is how we are going to build a OR gate using a NAND gate. So we are going to apply De Morgan's law over here. So I'm going to get A bar, B bar, and A bar dot B bar the whole bar, which is nothing but A double bar plus B double bar, which is nothing but A plus B. So this is how I'm going to build a simple OR gate using a NAND gate. Now, let's say if I want to build a simple NOR gate using a NAND gate, then how to build this? So this is how we are going to build a NOR gate using a NAND gate. Now, so I'm going to take A bar and B bar from these two NAND gates, and I'm going to give it to the third NAND gate so that I'm going to get A bar dot B bar the whole bar, and I'm going to give it to one more NAND gate so that my expression is nothing but A bar dot B bar double bar, and it is nothing but A bar dot B bar, so I'm going to get A plus B the whole bar. So this is how I'm going to build a NOR gate using a NAND gate. Now, let's say if I want to build a XOR gate using NAND gate, then I'm going to basically implement this expression using the NAND gates. Now, how to implement this? So this is how we are going to implement this expression. Y is equal to A XOR B. Now, what are we doing basically here? We are going to get A dot B the whole bar, which expands to A into A bar plus B bar the whole bar. And here we are going to get B dot A dot B the whole bar, which is nothing but B into A bar plus B bar the whole bar. Now, if we are going to again perform the NAND operation between these two, we are going to get A bar B plus A B bar. So basically we need 1, 2, 3 and 4 NAND gates for implementing a simple XOR gate. Okay. Now let's say if I want to build a XNOR gate using this NAND gates, then how I'm going to build is I'm going to take, so if I want to build a simple XNOR gate using NAND gates, then I'm going to take one NAND gate over here and one more NAND gate, and the output I'm going to give to another NAND gate, which is basically acting as a NOT gate. So this is how I'm going to build a simple XNOR gate using a NAND gate. Now, if I want to build a NOT gate using NOR gate, this is how I'm going to build it. So basically I'm shorting both the inputs of a NOR gate so that it is going to behave as a NOT gate. Now, let's say if I want to build a simple OR gate, then I'm just cascading two NOR gates, that's it. So that I'm going to get a OR gate. So what is the expression we are going to get here? A plus B the whole bar, and here it is nothing but A plus B the double bar, which is nothing but A plus B. Now, if I want to build a AND gate, then how I'm going to build it? So I'm going to take the connections like this. This is nothing but my A bar, and this is nothing but my B bar, and the Q is nothing but A bar plus B bar the whole bar. Now, if I solve this, then what I'm going to get is A double bar dot B double bar, which is nothing but A dot B. So this is how I'm going to implement a simple AND gate using NOR gates. Now, let's say if I want to implement a NAND gate using NOR gates. Now, how to implement this? I'm going to take these connections like this: A bar, B bar, and this is nothing but A bar plus B bar, the whole bar. Now, I'm going to give it to one more NOR gate so that my expression becomes A bar plus B bar. The complement will get cancelled because double bar, right? So it is nothing but A bar plus B bar, which is nothing but A dot B. So this is how I'm going to implement a simple NAND gate using my NOR gates. So A bar plus B bar is nothing but A dot B the whole bar, right? So this is how I'm going to implement a simple NAND gate using NOR gates. So these are the alternate symbols which we can use instead of this gates. So simple NOT gate is represented by a bubbled input NOT, and a AND gate is represented by bubbled input NOR gate, and OR gate is implemented by bubbled input NAND gate, and NAND gate is implemented by bubbled input OR gate, and NOR gate is represented by bubbled input AND gate. So these are the alternate symbols of these logic gates which we can use when we are simplifying any problems. So that's all about this particular session. Thank you.